We're going to cover a lot of ground in part one, and in particular, I'm going to tell you about the four simplifying assumptions that are made in order to turn drum buffer rope into simplified drum buffer rope. Makes the situation and the implementation a lot easier, believe me. On the slide there, you can see just one of those, and that's around the shipping buffers. I'll explain a lot more as we go forward. I'm also going to teach you about where SDBRs shouldn't be used. There are plants where this approach isn't appropriate. We're also going to build upon our understanding that we gained in the efficient and unproductive video series about the role of inventory and how it is so critical in determining plant performance. I'll explain in a lot of detail, but basically we're going to drain the plant of a lot of the inventory that's already there. I'm going to show you exactly how we do that, and the mechanism is known as choking the release of raw material. I'm going to show you exactly how to do that, how to develop a raw material release schedule, and how that plays out in the early stages of the implementation. I'll cover the buffer management priority system and how this guides operations on the shop floor. And I'll also show you what happens in the early stages of an implementation when we choke the release and we implement the buffer management priority system and how this affects plant performance. We'll talk about what happens when the initial choke period has completed and how we go about identifying a capacity constrained resource or a CCR. I'm going to take you through the five focusing steps of the theory of constraints and how we use that as a framework to guide our improvement. And in particular, I'm going to show you 12 different ways that you can improve throughput at the capacity constrained resource. And at the end of all that, you should have achieved these learning objectives. You should understand the four simplifying assumptions that SDBR makes. You should understand where SDBR shouldn't be used. And you should understand the four key elements of SDBR, namely choking the release of raw material, buffer management, dealing with CCRs, and ongoing improvement, which is a critical element of SDBR. And at the end of all that, you should understand why your production lead time should be reduced by at least 50% and your due date performance should be at or around about 99%. You'll also understand why the SDBR approach exposes significant amounts of capacity that you can use to grow sales without growing costs. Obviously, that means more profit. But you'll understand a focused, robust, and ongoing improvement process that continues to improve your manufacturing system over time.